Hello, so in today's video, we're going to look at an example of using the sine rule. So the sine rule is what we did in the previous video. We proved that this result here is true. So a lowercase a over sine capital A is equal to b lowercase b over sine capital B, which is equal to c over sine capital C. So the capital letters represent the angles, the lowercase letters represent the sides. So we've got an example here, and this is an example where we can use the sine rule. So let's call this angle here A. Let's call this angle there B. So therefore, that's going to be C there. The opposite side to the capital A is going to be our lowercase a. So this 10 centimeters is our lowercase a. And this over here, this question mark would be our lowercase b. So we've got a capital A, we've got a capital B, we've got a lowercase a, lowercase b. We could actually use the sine rule. So we can use this part of the sine rule here. So we only need to use one part of the sine rule. We don't need to use the triple equation. We can just use one equation from that triple equation. So what we can say using the sine rule is that a, so 10 divided by sine of the opposite side, so sine of 45, is equal to the question mark that we don't know, divided by sine of 60. So then what we can do is multiply both sides of that equation by sine 60. So if we multiply both sides by sine 60, we get that this question mark, this AC length, we just call it AC, is equal to 10 times by sine 60, all divided by sine 45. So sine 60, we should know that's going to be root 3 over 2 using our exact trigonometric values that you probably would have seen before. So obviously you've got sine 30 equals a half, you've got sine 45 equals 1 over root 2, and you've got sine 60 equals root 3 over 2. So using sine 60 as root 3 over 2, this can be root 3 over 2 times by 10, and then divided by sine 45, which is going to be 1 over root 2. So the final answer, we'll get 10 root 3 divided by 2, divided by 2, and then divide that by 1 over root 2, which is the same as multiplying by root 2. It's multiplied by a root 2. And so what we get, root 2 divided by 2 is actually just going to be 1 over root 2 again. So we're just actually going to get 10 multiplied by the square root 3 over 2. And that would be our final answer. So this missing length there would be 10 square root 3 over 2. And that's again because we've got 10 root 2, but root 2 divided by 2, root 2 divided by 2 is the same as root 2 divided by 4, because square root of 4 is 2, and that's just going to be 1 over root 2, because it's the square root of a half, which is square root of 1 over 2. So that's how you would calculate this example. So in general, you can use the sine rule in the following two cases. So when you are given two angles in a triangle and one side, you can use the sine rule to find another side of the triangle. So for example, if you've got an angle there, they give you that there, they give you that there. Then therefore you can actually know this side there, because angles in a triangle are up to 180. So if you know all the angles in a triangle and you know one side, let's say this side there, then that means you can work out either of the other sides using the sine rule. And also when you are given one angle and two sides of the triangle, so instead one angle and two other sides, you can use the sine rule to find the one of the angles opposite one of the given sides. So for example, if you've got a triangle like this, if you've got one angle there that you know, so let's say you know that angle, let's say you know this side there and that side there, you can therefore use, sorry, let me if I do the y down here, so we know the opposite side there, we know a side there, we can use the sine rule to work out that angle there, the angle opposite the x there. So that's how you can determine when you can use the sine rule. And this was just an example of how you can actually apply the sine rule in a real example.